Okay, so let's get
Mhm.
it's good. Recording in
Thank you.
progress. Yeah. So good to see you all. If I can see about two people here, but that's cool. But thanks all for coming along. And I want to talk to you about the impact of technology, positive or negative, and that's what we've got to decide in the next 15 minutes within this talk. So let's have a start at this amazing picture. And this was taken by Bill Anders on Apollo 8 in 1968. It's quite an extraordinary, I think probably one of the greatest images ever taken of our planet. Apollo 8 didn't land on the moon, but this is across the surface of the moon and shows this beautiful, beautiful planet that we live on. Quite a gem within our solar system. 72% oceans, of course, and then the land, you can see the greenery of the photosynthetic organisms on the planet and the circulating clouds and water and the hydrological cycle basically that's so essential to this planet. But we've managed to completely destroy it or done our best to destroy it through soil erosion, salinization, which is a massive issue that's underplayed very much. But like for instance, Australian and Chinese soils, there's 25% of those soils can't be used anymore because of the salt in them. Eutrophication, global biodiversity collapse, and of course, climate destabilization, which I know this group is focused on. And we've really started off with Malthus's Horsemen of the Apocalypse back in about 1780, where he pinpointed famine, disease, and war as being these significant issues. And our modern Horsemen of the Apocalypse that we have released include climate destabilization, pollution, especially from agriculture, to address the famine, and the diversity collapse. But these things have ended up producing and will end up producing more famine, disease, and war. So we find ourselves in this incredible cycle, really, in that the solutions we've put forward have ended up creating further issues. And that's a really big problem for our generation and the next few to come. And I go back to James Hutton. You know, we got the James Hutton Institute in Aberdeen, and we've got one in Dundee as well. And where he said, I consider the Earth to be a super organism, that its proper study should be that of physiology. So, how does that study of physiology help us in terms of what AI should be doing and the consequences of what it is doing? Well, I want to welcome you to the Earth system, and I want to try to explain that very briefly what the Earth system actually is. And it's a lot more than just birds and butterflies fluttering around some beautifully preserved forest. It's the arbitrator of our future. The Earth system, first of all, is a complex system, and therefore it brings with it all of the characteristics of complexity that we find in a complex system. It is, first of all, non-linear. It's not like a train line where we're going from A to B through a number of given stops and we can predict what they are and we move through that. Rather, it's a much more complex thing. Each component is interacting with every other component, and the component interactions vary depending on the dynamics of the system. So we've got a non-equilibrium status and we've got a dynamic variable interactional conversation going on. And that's very important. We end up with tipping points, we end up with ecotones, we end up with very drastic changes potentially in terms of what can happen here, and very unpredictable as well. Complex systems are also emergent. One plus one doesn't equal two. This is a real challenge for us. It's not Legoland. You can't fix it by adding a brick onto the top or adding a couple of bricks over on one side to create a different shape. It doesn't work like that. There are conversations happening. And the complex interactions of the parts or the components, and we are a component in this, give rise to properties that only belong to the whole, the entirety of the system. There's no place for biomimicry here. We don't pluck something from an organism that seems to be doing it quite well and introduce it into our industrial processes, as biomimicry would suggest. We're not mimicking anything. We're in a real world. We're in a real active Earth system. And we must remember that. So biomimicry has got no place in Earth system complexity and function. Okay, let me introduce you to a little character here to explain the third aspect of this, and that is suboptimality. And this is the most difficult thing to grasp in complex system theory. Let's meet Susie the squirrel here, and a wonderful squirrel she is, and a red squirrel, of course, she is as well. And here Susie was walking home from the forest back to her Airbnb that she'd hired, and because she can't be bothered living in trees anymore. And she picked up the local newspaper called the Squirrel Advertiser, and it said, the headline grabbed her immediately. Are you a squirrel who's forgotten where you've hid your nuts? You need the Nut app. And wow, okay. And it's compatible with all handheld devices. It's got the latest AI technology, and it finds 99% of your nut stashes, plus some you didn't even bury. Finds other people's nut stashes as well, other squirrels. This is amazing. So she goes and gets this nut app and tells her friends they've all got it, and now they're getting all the nuts that they buried the previous winter, the previous autumn, and they're feasting, growing stronger. And the next spring, they reproduce in a much better way. There are lots more squirrels now in the forest. But of course, baby squirrels need eggs. And the adults, not everyone knows this, the adults take bird eggs and feed them to the baby squirrels because they're high in protein. And that's what's needed in the early stages of growth, of course. So this greater increase in the population has led to a massive explosion in squirrels and a massive increase in bird egg eating, basically. That means the bird population collapses the next year. Now, these birds would eat the sort of pests off the coniferous and oak trees that are producing the pine nuts and the acorns for the squirrels. So they start to crash. And after a few years, they are devastated by disease. And of course, this leads to a collapse in the food for the squirrels for most of the year. They're no longer bird eggs either, because they've all gone. And so the whole population of squirrels collapses. Now, you might say, what a stupid animal this is to get this nut app. How foolish were they to optimize for their own survival? Because by ignoring the natural ecosystems that were functionally crucial to them, they have indeed ended their own ecological space. They've closed that off and they have nowhere to actually exist. How stupid. But yet, if you reflect on this, this is exactly what we are doing. We're optimizing for the human condition to the detriment of the Earth system's environmental functional production. And of course, we rely on that. And it would be very foolish, a strategy of doubtful value, to actually ignore the Earth system because it is the essence of our very existence, and we are part of it, whether we like that or not. So we mustn't optimize. Suboptimality at any given level is a sign of a working system. We see this in DNA correction. If DNA correction was perfect, there would be no diversity created within the genetic code, and therefore there would be no variation that would respond to changing conditions on the planet. And so suboptimality is central to DNA correction as well. Too much DNA correction, of course, leads to no variation, but too little correction leads to a disastrous consequence in terms of genetic mutation. So there is an intermediate level of suboptimality that we need to find to have the optimal overall Earth system function. Optimization for any single level is disastrous to the system. It is where we have gone wrong in so many ways. We can think of agricultural production as well. We've optimized that, but the eutrophication as a consequence of that is disastrous for the aquatic habitats on our planet. And AI risks this same thing. In fact, it accentuates it. It's aimed at efficiency at the moment. It's aimed at optimization. And by optimizing, we will lead to our own demise as such. So what I'm suggesting is we need a suboptimality operon that works within artificial intelligence. It needs to be listening and it needs to be sub-optimizing to the correct level. And that's an important thing. We'll come back to that. Now, of course, how do we know how suboptimal we should be? How much noise should we make within our given habitat and niche? Well, this all depends on real-time feedback. Systems are dynamic. We've seen that with nonlinearity. It's continually changing. So we need constant feedback, and that's really important in order to track emergent nonlinear change. How close are we getting to regime change? We need to understand that. We need to have large ears in order to monitor emergence and nonlinearity and to calculate suboptimal operand value. How much suboptimality do we need within the artificial intelligence process? And the Internet of Things and 30 billion smart devices exist on the planet already. So these can be used quite adequately to get the feedback in terms of monitoring our ecosystems. The fifth and final aspect of a complex system is self-organization. Complex systems self-organize. It's an amazing process. You think of the last mass extinction with the dinosaurs. What happened there was that there was this great sort of shadowing of the Earth by the dust in the atmosphere, both from probably a comet and secondly the Deccan Plains, a massive geological event in India. And these created a huge amount of dust, and as a result, the incident radiation was massively reduced. Now, the system then collapsed, but it rebuilt. But it didn't rebuild in terms of what it was before. It was completely different. It was a restoration of function. So we had our producers, primary consumers, secondary consumers, and detritivores, but they weren't the same characters second time round. The dinosaurs were gone. This allowed the mammals to rise. So it was a functional rather than a structural reorganization. And that's very, very fundamental. So here we have our Earth system, and here we have you and me. We have economics and society functioning happily within it. But unfortunately, that's not where we are at the moment. Economics now has become the dominant element. Our well-being we see in reference to economics, and the Earth system up here in the top left is just merely a sink and a source now. And therefore, that creates a significant problem for us because what happens is that we actually are excluding ourselves from the Earth system. It's like the angel throwing Adam and Eve out of the Garden of Eden, where they were being quite happily hanging out. But they were thrown out and dismissed. And if our ecological space shrinks to nothing by our own activities through a regime shift in the Earth system, then we'll find ourselves excluded from it. I want to now take one more concept in here that's very important, and that's called the pluriverse. And what we have on the planet is a whole set of different worlds. We've got the tropical rainforest, the temperate rainforest, the tundra, the savanna, and so on. And each of these runs in its own way. And as such, wherever we are on the planet trying to practice our economics, and wherever we are trying to practice our artificial intelligence in terms of its control and organizational powers upon the processes that are happening, we need to have a pluriverse of suboptimality operands. And that's something is very important. I've been writing about this quite a lot recently. See, here we have our ecological pluriverse. We have all of these different biomes. Within one country, we can have many. We can go up to a tundra in the Munros in Scotland, and we can go down to a temperate rainforest in the Caledonian forests of Scotland, for an example. So we've got lots of these different worlds, and they operate in different ways. We've also got a sociological pluriverse. This could be cities, large cities, where 70% of the world's population exists and abides at the moment. Or we have many, many indigenous people and nations that are tuned to the ecological pluriverse. So we have a mapping of human behavior onto the ecological pluriverse. We have many worlds coexisting in sociological ways on top of the many worlds that are existing in ecological ways.
From Lerwick.
What's that? Sorry,
It's
I can
buzzing.
hear someone. Abby, I can hear you. No, no, who was that?
Sorry,
I can't hear. Okay, will I just continue? I've
please do.
plenty of time left, according to my watch. Okay, so we've got these two. Let's just take two of these habitats, two of these ecological pluriverses, the tundra boreal and the tropical rainforest. Tundra, extreme seasonality, significant recent climate change, limited diversity, slow recovery, storage economy, slow recycling, and migration transhumance. In the tropical, we have stability and consistency, little recent climate change, huge diversity, rapid recovery, spending economy, and rapid recycling with an establishment settlement pattern. So we see that these two different ecological pluriverses have different economies and different behaviors in terms of humans. And that's very important. These things are mapped on. So where do we go from here? Well, let's untangle this. First of all, what can technology offer in this journey towards a sort of pluriverse sensitive way ahead, and most importantly, an Earth system sensitive way ahead? And is human intelligence the best template for that? Well, the ability to achieve goals is a wide-ranging thing in intelligence. It's very, very important. And this definition works for many different levels. Westerhuis has said all forms of life, microbes to humans, exhibit some or of all characteristics consistent with intelligence. And so animal intelligence has been thought of by Wilson as the best model for AI, not human intelligence. This swarm intelligence, collective behavior of a group of entities put forward by Condorcet, he demonstrated the larger group was more likely to make the right decision. So swarm intelligence in animals is thought to be a great example. Plant dispersed intelligence. Every growing tip on a plant is a coordinating center. There's no brain, but this thing is building up a spatial understanding. 14 million root tips in the average rye plant. And so in many ways, this resembles a small version of the Internet of Things. And so it's already happening there. Also, these plants are all connected together through ectomycorrhizal fungi, which is a very powerful thing. So we've got different species acting together and coordinating the response. And this is pointing towards a greater understanding beyond just the species. So interconnectivity can lead to this much greater swarm effect between species and even between kingdoms. Microbial intelligence, we know about that. There's a community memory, there's data sharing, bacteria swap DNA through plasmids. And this is because bacterial DNA changes very quickly. And this sharing allows an amazing sharing of information. And the Internet of Things is bringing that too. There's no doubt about that. Finally, quorum sensing, the heart of bacterial intelligence. We get this feedback and communication. Bacteria are critically aware of the narrative around them. And this is very much reminiscent of the storytelling of ancient civilizations. This photograph is taken in Morocco, where there's a lot of this storytelling that still goes on, in Casablanca specifically. So last few slides then, ecological intelligence compared to Western human AI intelligence. It's non-linear, it's emergent, it's suboptimal, it's real-time feedback, and it's self-organizing. These are the qualities of the system, whereas we tend to pursue linear, reductionist, human-optimized, silo mentality, Lego brick approach. So this is very different than the current AI intelligence, which is designed by Western human intelligence and mapped onto it. And this is a very different thing. But this is actually the survival way here on this side. So we find ourselves trapped in the big top, really, of this non-systems approach, of this selfish approach, this what's best for me. I'm all right, Jack, the individualism. And actually, the rest of the world doesn't work like that, and it never has. It's all been about systems theory, that's recovery from devastation and its survival. And so we need to escape from the big top. Bioparticipation rather than biomimicry and Legoland is the key thing. We must step out of the big top of human-centered thinking and step into a meaningful integration through the relational self. That's crucial. And Thomas Berry talked about this. We go from a period when humans were a disruptive force on the planet Earth to a period when humans become present to the planet in a manner that is mutually enhancing. And that's what we need to do. And that's what we need AI to do for us as well. And that's why it's important. So all other levels of intelligence work within the system and are governed by it. Animals, plants, and microbes are expressing the connected intelligence of the Earth system. Only within this greater church can any of it be understood. And the why questions are resolved within the greater system. And so to finish then, we've got a certain key message here. We need a more than human AI and we need a more than human human, more fundamentally. So all of us need to make these changes. Earth system centered, feedback and suboptimality operons that are pluriverse relevant, finding the balance within how much noise to make, reintegration within the greater system, and the pluriverse perspective. So that is really it. And thanks so much for listening. I hope you've got something from that, and I look forward to your questions and challenges later on. Okay, that's great.